This will be a quick tutorial on how to work problems using the combined gas law. The combined gas law is a larger formula that is derived from a combination of Boyle's law, which is P1 V1 equals P2 V2, Charles' law, which is volume over temperature equals a new volume over a new temperature, and then Gay-Lussac's law, which relates pressure and temperature. And the combined gas law states that P1 V1 over T1, so the initial pressure volume over initial temperature, equals the final pressure times the final volume over the final temperature. And please remember that temperature must be in Kelvin. Okay, let's check out two problems. So a hot air balloon has a volume of 7,500 liters at 270 K and a pressure of 1.2 atmospheres. What will be the volume of the balloon if the pressure changed to 0.9 atmospheres and the temperature decreases to 230 Kelvin? Just looking at this problem, I see I'm given a lot of values, and I know that I can't use the ideal gas law because I have variables changing. So my temperature is changing. I see a T1 and I see a T2. I see a P1 and I see a P2. And then I have V1, and I've been asked to solve for V2. So I know I can't use the ideal gas law, and I'm going to need my combined gas law. Let's check our units. Volume needs to be in liters, temperature Kelvin, and then pressure. As long as it's in the same unit, and I see they're both in atmospheres, we are okay. We don't need to do any additional conversions. So let's calculate the new volume of the balloon once the pressure and temperature have been changed. So P1 is 1.2, that's atmospheres. And then V1 is 7,500 liters, and that's over 270 K equals, okay, P2 is 0.90. I'm solving for V2, and then that is over 230 Kelvin. Because these are set equal to each other, I can just use my cross multiplication. So if you're not sure what that means, I can multiply all of these values, then multiply all of these, and use algebra to solve for V. So I'm going to do that. 1.2 multiplied by 7,500, and then by 230 is 207 with 4 additional zeros, and that equals 0.9 times 270, which is 243x, or V2. So then I'm going to solve for V2. Let me divide both sides by 243. And I'm going to find that my new volume has, not significantly, but it has increased quite a bit to 8,518.52 liters. So this would be the answer for the first one. Okay, and for the second one, let's take a look at this. The volume of a gas at STP is 22.4 liters. At 12 degrees Celsius, the volume of the balloon changes to 55 liters. What is the new pressure? All right, upon first glance, I don't see many values, but we've actually been given a really valuable piece of information. Not only do we have this information here, and I'm going to highlight it in blue, we see 22.4 liters, and the balloon is changing to 55 liters. So just that word changing indicates I need the combined gas law and not the ideal gas law. I also notice I have a volume of 12 degrees Celsius, which we know we're going to have to convert to Kelvin. That would be 285 Kelvin. And then the other piece of information I've been given that's really valuable are these three letters here, STP. So if you'll recall, STP stands for standard temperature and pressure. And that is a pressure of 1 atmosphere and a temperature of 273 Kelvin. So I've actually been given P1, T1, and then this is a V1, and this would be my T2. My V2 And my new pressure means I'm solving for P2. So now we just have to plug in our information and solve. So that would be P1, which is 1 atmosphere, times V1, which is 22.4 liters, over 273 Kelvin, equals, that's going to be P2, and then times 55 liters over 285 Kelvin. Again, I can use cross multiplication, so these, and that's going to give me 285 times 22.4, 6384 equals 55 times 273 is 15015, and then times P2. So to solve for my P2, I need to divide. I'm going to get 0.425, and then let's see, my original volume or pressure was in atmospheres, so this will be in atmospheres as well. So there are two different types of problems you can work. I hope you found this helpful.